Alright guys, this will be our first video for Friday, May 1st for AP Euro. We're picking up with the Second Industrial Revolution in the late 1800s. By the middle of the 19th century, Europe had undergone a dramatic process of economic expansion. These economic changes, sometimes referred to as the Second Industrial Revolution, and their impact on human lives may have been even greater than what occurred during the initial stages of industrialization. Steel. The label age of steel is an apt one for the second half of the century. Previously, steel production was expensive. In 1856, Englishman Henry Bessemer introduced a method that became known as the Bessemer process that produced steel in far greater quantities without increasing cost. A few years later, William Simmons, a German, introduced an even better method of making steel that produced higher quality product that significantly reduced costs. Because of its strength and durability, steel became the metal of choice for buildings and ships, resulting in a revolution in architecture and shipbuilding. Electricity. Few developments have affected the way people live their lives as significantly as the invention of the means to harness electrical power. In 1879, Thomas Edison invented the incandescent lamp. 2 years later, the first electrical power station was built in Great Britain. Soon after that, European cities began to be lit after dark, and populations moved through the streets of a city more effectively when the introduction of electric tramways. Electric lights made cities far safer, even led to the expansion of nighttime activities in London and Paris, where the late 19th century saw a tremendous growth in the number of public opera houses and theaters. Transportation. The second half of the 19th century witnessed many significant developments in all forms of transportation. Europe's rail network expanded dramatically. By the end of the century, well over 100,000 miles of track had been laid. In 1869, the French built the Suez Canal, though it was the British who gained control of the canal in 1875, eager to ensure their continued use of a waterway that almost halved the amount of time it took to travel from Great Britain to India. Speedy clipper ships began to set records for across the Atlantic Ocean, though by the end of the century they were being replaced by steamships. Trains and steamships used the ice-making machines that were introduced in the 1870s. They were able to transport perishables around the world and made the United States, Australia, and Argentina major providers for European provisions. In 1885, Carl Benz invented an internal combustion engine powered by gasoline. Automobiles, however, would remain a plaything for the very wealthy until Henry Ford started producing Model T in 1908. Finally, a whole new era of transportation was opened up when Orville and Wilbur Wright brothers, who background was in the bicycle building, launched the first successful airplane at Kitty Hawk, North Carolina, in 1903. Communication advances in education. Britain was the first European nation to establish a national postal system with users able to send a letter for a penny, affordable to almost all. The development of universal public education also meant that more people were inclined to communicate in writing. In 1844, the first telegraph line was completed, and by the second half of the century, Europe was covered with telegraph lines. In 1876, Alexander Graham Bell invented the telephone, and Germans were making 700 million calls per year by 1900. Some of those calls might have been to make social arrangements around the new entertainment options of the age, such as attending motion pictures, first shown publicly in the 1890s, while stay-at-home sorts could enjoy the phonograph, the record player, invented by the incredibly prophetic Thomas Edison in 1877. Other scientific developments. Science began to play an increasingly important role in industrial expansion. In particular, the second half of the 19th century produced a series of major developments. While this trend was to continue into the first decades of the 20th century, in many ways, the optimism that one could sense in the 1880s concerning the world of science was not to be found some 40 years later. Even before the First World War delivered a terrible blow to the belief in rational progress, scientists were revealing that nature was incredibly complex and that many questions would remain unanswered for at least some time. Of the basic assumptions concerning the workings of the universe were under attack. For example, the introduction of synthetic dyes revolutionized the textile industry. The invention of man-made fertilizers led to increased crop yields. The invention of dynamite by Swedish chemist Alfred Nobel made it possible to blast tunnels through rock and remove those hills that nature had placed in inconvenient spots. Nobel, however, was horrified by the potentially destructive uses of his invention. In his will, he entrusted money for a prize to be given to his name to those who serve the cause of peace. Increasingly, the 19th and 20th centuries witnessed greater specialization in the sciences as scientists provided some of the key foundational work in areas such as physics and chemistry. Some of these developments included the following. Michael Faraday produced groundbreaking work on electricity and electromagnetism. Amateur scientist James Joule defined many of the laws of thermodynamics. In chemistry, Dmitry Mendeleev developed a periodic table arranging the known elements by atomic weight while leaving empty spaces in his table for those elements that then predicted but not yet known. 1895, Wilhelm Röntgen made an accidental discovery of X-rays. In the following year, in another fortuitous accident, Antoine Henri Becquerel discovered radioactivity. although he did not follow up with this additional work. That task would be undertaken by the Curies, Marie and her husband Pierre, who had spent their lives studying radioactivity. In 1910, 4 years after the death of her husband, Marie Curie isolated radium. In England, Ernest Rutherford laid the groundwork for understanding of the atomic structure by showing the atomic particles had a central core called the nucleus. Rutherford had once famously said that the theory in physics wasn't any good unless it could be explained to a barmaid. Yet his own work became part of an increasingly complex body of knowledge that left many ordinary people feeling alienated from the world as revealed by science. As a young student, Max Planck was told there was nothing further to be discovered in physics, yet his work was to revolutionize the field. In 1901, he devised a theory based on the idea that energy did not flow in a steady stream, but was delivered in discrete units or quanta. His quantum physics spelled an end to the dominance of mechanistic interpretation of physics that stemmed from the work of Newton. Further undermining Newton's concept of the universe was Albert Einstein's special theory of relativity, where time, space, and movement were not absolute entities, but understood to be relative in accordance with the position of the observer. Philosophy. Just as scientific inquiry was revealing ideas and principles that appear to be less than rational, philosophers such as Friedrich Nietzsche, for a time a professor of classical languages at the University of Basel, began to question and even to reject the ideas of the 18th century Enlightenment. Nietzsche's most influential work, the Thus Spake Zarathustra, he argued that it was necessary to break free from traditional morality, while he famously proclaimed that God is dead. It was necessary, according to Nietzsche, to kill God because religion was at the center of Western model of civilization that he despised. Nietzsche hated the Germany created by Bismarck, and instead yearned for the emergence of an artist, warrior, Superman. Unfortunately, after his death in 1900, his pro-Nazi sister was in charge of his literary estate, and she edited his writings to make them supportive of Hitler's extreme nationalism and anti-Semitism, two modern chauvinisms that he, in fact, despised. Psychoanalysis. Sigmund Freud, the father of psychoanalysis, took the methods of modern science and proposed to find a way to treat mental disorders by delving into the human subconsciousness, using what he referred to as the talking cure. As he spelled it out, the interpretation of dreams, Freud believed that dreams reveal the inner workings of the subconscious world and devised a list of Freudian symbols, items or events that appear in dreams that actually represent other items or events stored in the unconscious. In Civilization and Its Discontents, a book written in his more pessimistic later years, Freud questioned the very premise of continuous progress for the human race and instead posited that despite attempts to suppress it, violence lies at the very core of our being. Advances in medicine. The beginnings of modern Western medicine took root in the 19th century, marking the first time in history that going to the doctor was not such a bad idea. Surgery, previously dominated by practitioners who bragged about their ability to remove a leg in under 90 seconds, was transformed in 1846 when American dentist William Morton began to introduce anesthesia in the form of ether, followed by the use of chloroform and anesthesia a few years later. Overall, the most significant change in medicine in the period was the experimental method found in the sciences was applied to medicine. Applying the experimental method, Louis Pasteur discovered that microbes, small invisible organisms, cause diseases. Pasteur also explained how vaccines, which had been in use since the 18th century to fight against smallpox, worked within the body by stimulating the immune system to produce antibodies after coming into contact with a weak form of bacilli. The English surgeon Joseph Lister, building on Pasteur's discoveries, initiated the use of carbolic acid as a disinfectant during surgery. A Hungarian doctor, Ignace Semmelweis, made childbirth much safer for women, demonstrating that if doctors and nurses thoroughly washed their hands prior to delivery, it could dramatically reduce the number of women who died from what was known as childbed fever.